So today we'll discuss a problem about heat pump. So the problem goes like this. A building has to be maintained at 18 degrees Celsius. So ang imuhang building dapat ang iyang temperature kay at 18 at all times. A heat pump is required for this when the temperature outside the building drop to -6. So ang temperature sa gawas kay -6. The building loses heat at the rate of 120,000 kilojoules per hour. So what is the least, the question is, what is the least power required to drive the heat pump? So ang heat pump is just na siya, baliktad na aircon or baliktad na ref. Ang purpose, so let's try to draw the problem. It looks like this one. Nakay building. So ang itsura sa imong building kay isa mo na siya. Building. So, the temperature of the building must be maintained at, so gusto ka nga ang temperature sa building kay at 18. Okay na? So, T sa imuhang building is at 18. And temperature sa imuhang surroundings kay unsa man? -6. So, ang sa gawas, -6 ang temperature. Meaning, sa mga country ni siya na, country ni siya na mga, mga country? Temperate no or western no kanang ga-freeze. So diani unsa di mong buhaton na kay dapat heat pump daw ibutang para the purpose of a heat pump is to transfer heat from the low temperature paingon sa high temperature. So ingon ana ang kuan. So kung na kay heat pump dani, shall we say ana daw kunuhay padilig na mo yang sketch no. Ang purpose niya is i-move niya ang kuan no, i-move niya ang heat from magpasulod siya og heat dapat dana sa imong building QH. Okay? Ahamo niya nakuhaon nga heat gikan sa cold na kuan no, murag iya mo na yang buhaton. Gina move niya ni siya kaning QC diani no. Gina from diri sa gawas yan ang gina push ning heat paingon sa sulod no. But that can't happen naturally kay the flow of heat must be from high temp to low temp. Mo na ang natural flow. So this can only be done with the help of by doing work, no? Nagdala ka kinasupply nimo work ang imong pump in forms of maybe mo nang ginapangitan to power required work supplied per unit time. So by the way, anong ato man kailangan supplyan og heat ang imong building? Kay supposedly this building can be maintained at 18 assuming that the walls are insulated. So kung i-insulate mo ng building diyan na, meaning no heat will leak out to the surrounding, ma-maintain mo na. But in reality, you can't have complete insulation. So ang maitabog yun, there's a rate, this one, the building loses heat at the rate of 120,000 kilojoules per hour. So ahama na paingon nga heat. Paingon na siya sa gawas, no? So kana nga heat nga ni gi-release sa building is has a value of 120,000 no, kilojoules per hour. Meaning, to maintain this building at 18, dapat kaning amount niya gina-release mag-compensate. Meaning, mo na dapat ang value sa QH nga mo gina-supply. Kaya diba, knowing kung mag-release ka og heat, mabugnaw man na siya from the idea of sensible heat, no? MCP delta T. So, kung na i-release nga heat, mabugnaw ang imuhang, mas mabugnaw ni siya. Eventually, mahimo ni siyang so, muna to siya, no? Nagalit ko. So, kaning heat, dapat masupply nimo kaning QH actually is 120,000 kilojoules per hour. So, ang question lang karon is, how much work, no? Minimum work. When we say minimum work, efficient kay mong heat pump, more or less, it will approach Carnot efficiency. Or, ang imong process kay ideal kay, no? In that case. So, so din ang heat pump. So, let's try to look heat pump this way. Ang heat pump simply naka-input na work, naga-input ka og work, okay, W, then in that case ginapasulod pug ka og kuan og QC, and dapat na kay product, no, ginabuga na QH, no. Ang eventually ang heat pump gyud is kana heat pump nagakuha siya og heat, no, from the surrounding, which is at colder temperature. Sabi sa this temperature is at TC, gina expel niya sa higher, no, higher temperature TH, and by that kailangan work i-apply. From the first law of thermodynamics, for this system, we can have delta, okay, for a flow process, no, assuming nga mao niyang imuhang kuha, no, sa imuhang heat pump naday kay or flow or non-flow lang ni siya, no, so meaning na work supplied to this heat pump, it takes in QC and QH leaves the heat pump. So from the first law, if we have the, shall we say, delta U is equal to Q plus W, okay, and kanisya will mean kung at steady state ni mo kanang heat pump, no, kung steady na ni siya og function, the temperature of the heat pump will not change, therefore its internal energy won't be changing with time. So at steady state, this will be eventually 0. It will then lead you to Q plus W. So let's try to analyze unsa ning mga Q diyan, no? In this case, Q is unsa man ang Q? It will of course be Q leaving minus Q entering. So it will be QH minus QC. Tama ba? No? Plus W. Therefore, if we try to compute for work, okay, work must be equal to, work supplied to the heat pump must be equal to QH, QC minus QH. Or basahin mo na. Now, when we want to calculate for minimum work, so makompute natin no, kaya naman tayo QH. Kabalo ta QH is, so ang QH 120,000 kilojoules per hour. But QC, wala tayo idea kung unsa na ang QC, no? Unsa na ang QC. So think of the Carnot efficiency. And for a heat pump, mo ni ang kuan. They call this actually COP, coefficient of performance, and if we try to look at that, COP for the heat pump is just like really efficiency. It's just the ratio of, I'll say COP, it's just the ratio of what do we want to get. Unsa day ang heat pump? Unsa purpose sa heat pump? Unsa tong purpose sa iya? Makakuha ta og QH, no? Makasupply ta og QH. So COP, or the coefficient of performance of the heat pump, is simply QH, okay, over the performance or efficiency is simply how much you get from your input. Unsa man imong input dani? You invest on work done to your pump. So mo nang imuhang kanang, so mo nimong COP. QH is your desired output, no? Heat pump, gusto ka makakuha siya, makaproduce siya og QH para ma-maintain nimo ang temperature sa imong building. So QH over work. Now, let's try to express this in terms of temperatures. Kaya kaya man gini siya buhaton in terms of temperatures. So here we could re-express work in terms of, based on this equation, work can be written as QC minus QH. Okay, so you can have here QH over QC minus QH. And now, happily, we could express this now in terms of temperatures. This is the idea of Carnot. QH is taken from, is supplied to what temperature? The higher temperature, TH. And QC is removed from what temperature? Sourced from TC, no? The colder temperature. So QH could be also as TH. So ingana ang mo ni ang power sa Carnot analysis. The QH could be replaced by, but these ratios could be replaced by that, no? QH i-replace mo og TH, and QC i-replace mo siya sa temperatures kung asa sa gi-source out or gi-supply. In this case, TH, so kanida siya ma-express mo siya in terms of TH, TC minus TH. And in that case, we can then have QH over W, no? So bali ang atong gina-supply is, so modern ni siya, no? QH over W. So therefore, if we want to look for W, the minimum work, saan natin siya pag-solve. So from here, work could simply be TH. Oh no, TH. W man, no? So saka nimong W ba? Then dirahon nimo dire. It will be what? QH times TC minus TH over TH. So we now will then have simple substitution of formulas, no? So we'll have here 120,000 kilojoules. Oh, pangit na like kog agi. 120,000 kilojoules per hour. Never mind the unit. So times TC minus TH. So what's TC? It's at negative. But take note, diyan ba? Daan yung pinaka-dagan og mali, no? When we have temperature ratios, the temperature must be expressed in terms of absolute values, no? But kung TC minus TH lang, pwede na siya dili nimo absolute value pag-express. Kaya anyway, delta T absolute and delta T nga Celsius kay pareho lang na sila. So you could have here negative 6 minus 18, right? TH, what's TH? 18. So negative 6 minus 18. How about your TH? So daan ay dapat dili 18 nimong ibutang, no? Kaya dapat absolute values man. Actually, pwede naman ng negative 6 i-plusan nimong 273, 18 plusan nimong 273, pwede lang gihapon. Pero dapat dire sa denominator nagit siya plus, so that's 18 plus 273, that's what? Ilan man na siya? No? 291, no? Yung nilindi. 291.15 or 291 lang, roughly that value. And therefore, with this, we can get work equal to, no? Nanatay value sa work. Negative lagi na akong mga answer. Negative? Oh no. 9.89 or 9.9, no? Tama ba? Negative 9.9 kilojoules per hour. 9.9, ang unit anak niya will be kilojoules per hour. If we convert that now to, shall we say, kilowatts, so that means we multiply this by 3,000, no? That's kilojoules per second. Multiply this by 3.36. We'll be having divide, no? Kaya answer, kung divide mo na siya, negative 2.75 roughly that value, no? Negative 2.75 kilowatts. Therefore, when we say negative, what's the meaning ng negative 2.75? So makulbaan na tanong anong na yung mga negative. Kung makulbaan na galit tawag na yung negative, so okay lang na siya sa work, no? But what's the meaning anong negative? Negative means dapat positive ba, no? Kay work is being done to the pump man. Diba? Work, no? Supplied work dyan, eh. Wait. QH leaving, no? Leaving nimo is see. When we have this analysis, we must have, meaning a positive means mas dako ang ni-enter kontra sa ni-leave, no? Positive value of Q, di ba? Meaning ani, positive value of Q means mas dako ang ni-enter sa imong system kontra sa ni-leave. That's a positive Q. Meaning kung dako ang nisulod niya, gamay rang ni gawas, so gaining ang imong heat sa, meaning dako ang energy sa imong system. So kaniyang mali ba? Supposed to be this must be written as QC minus QH. No? So dapat QH ni siya, no? QH minus QC, no? And therefore, kanito mga formula, this must be, naman to yan? Dapat kani siya kay, wait. Dapat ni siya kay, oh, what's happening? So dapat kanino kay QH minus QC, And therefore, in terms of temperature, this will be in terms of TH minus TC, and this must be TH minus TC. This must be, no? Ang negative 18 minus 6 dapat ni siya, no? So, dapat 18 minus 6 minus negative 6, and therefore, ma-plus na sila, no? And eventually, we're happy that the result will just be exactly just changing the sign, no? And okay lang po na siya. So this is problem, actually, problem from thermodynamics problem drill. And this is, ang answer niya, kaya makita po din mo sa, nasa choices, and we're happy to have that, no? A. Thank you.